Hello and welcome back to the lab. Today on the bench we have not a Tektronix. This is a Heathkit IO 4550. It is here because it is ill. I've been requested to do some repairs on this, get it up and running, and I'll get into that. But I'm not going to plug it in. I have confirmed that it is very sick. Lots of issues with it. It kind of works intermittently, but nowhere near reliable. And we'll get into that. I haven't opened it yet, but it wasn't working, and then it was working, and the person who owns this was getting really frustrated with it, but also would like to move it along to a makerspace, and that got me looking at a few things. Let me start by saying thank you for everybody who's joined us here in the lab and continues to join us in the lab. I didn't notice it, but when I was looking at the content list on the YouTube page, this is the 100th video that we have put out to YouTube. So we're 100 videos into this project at this point, and the community that's building up around these videos has been absolutely fantastic. I love talking to everybody. It's just been great. So definitely thank you for being here and joining us. The other thing is, this particular scope is of significant personal interest to me because I know the person that built this scope. It's been a one-owner scope. It's never been anywhere else. It's never been sold. It's never been anything like that. This is also the exact scope that I had access to when I was very young. So this is one of the ways that started me down the technical road that I find myself in currently. So I don't care how much work this is going to take. Whatever this has to do, even if I have to rebuild the whole thing from scratch, this will work again. This does not have a choice. The tube is in great shape. It was well cared for. As you can see, there's zero burn-in on the tube. Everything is good. So we will be taking care of this scope completely. To that end, the person who put this kit together, because for those that are newer to this, the Heathkit stuff was actually sold as a kit. It wasn't sold as a pre-built unit, and that was one of the ways you could afford equipment when this was prevalent. Also, these tended to be mail order. You sent away for them, and they showed up in the mail, and then you spent a while putting them together. This is not a tech scope by any stretch of the imagination. It also did not carry a tech price tag by any stretch of the imagination. So it put it within reach to a lot of people who couldn't otherwise afford a tech scope. Back in the day, before mass production and things like that, tech scopes were more expensive than the family car. They were very, very expensive pieces of equipment, very cost prohibitive, and very hard to find. So a couple of things to note that are different is on this one, when I pulled this cover off, the graticule came with it. Whereas in a tech scope, the graticule's etched into the front of the glass. That'll cause two things. One, that'll cause a slightly derating of the accuracy of the scope. I'm sure that was taken into account with Heathkit when they did their accuracies on their spec sheet. And it also sets up a parallax error. So if you're off to the side, you guys through the camera are straight on, but I'm over here, so I'm looking at it this way. That'll cause measurement errors. Like I can see shadow here on the graticule from the light bouncing, going through and then coming back. So that can cause measurement error. So when you use a piece of equipment like this, especially with a grid that's not etched into the tube, you do have to look as straight on as possible. That's also true for needle-based meters and a few other things. This was very meticulously put together and worked flawlessly in the past. I do know it has done that. However, it has not aged well. So we're going to deal with a lot of time-related issues. So definitely going to be cleaning the controls and the switches Everything's very stiff, not working correctly. Going to give it a once over. I have been asked to do a recap of this scope to get some fresh capacitors in here. So we are going to do that, take care of that. And we're just going to go from there. Just kind of see how things go and what we can make happen. That's enough of me talking. Let me get the covers off and let's see what we're up against. Okay. And there we go. Definitely have some capacitors we're going to want to service. This one's going to be a challenge. We've got a multi-section cap, yes, with all 3 sections used. So shoehorning some capacitors in there is going to be easier than I thought because, yeah, okay. That's actually probably going to be easier than I thought. Okay. Yeah, I know what we'll do there. So definitely going to do some recapping on this one. I have to clean all the switches and the controls. Going to give it a good inspection. Like I said, this thing, time has been its enemy. It was well used and well taken care of. This is the dust. I haven't even cleaned anything, so this is the dust that was in there from the beginning. The switches feel like they could use some lubrication and cleaning for sure. And then because we have scope alignment gear in the lab, we'll actually align this thing with gear that was never available for when it was doing its alignment. So we're going to deviate from the prescribed alignment procedure, I'm sure, because I doubt anybody had a time mark generator or a PG506 that was putting one of these together back in the day, because those were technically not even created yet. It was still the type-based equipment. So very cool. Well, let's get into it. Okay, I've dimmed the lights in the lab so the camera will pick this up better. I am going to have to inspect this pretty good because one of the things that I've been asked to troubleshoot is an intermittent sweep function. And if I look, it caught the light just right. I don't know if the camera can see that coming through. Yeah, you can see a little bit. Let me get a pointer so I can point out exactly what's going on. Some of the stuff you want to look for, especially in this stuff that's been assembled for a long, long time, is right, if I get the light just right, yeah, right here, top side of this leg, you can actually see light coming through the through hole for the leg. So that's a joint that's cracked off, and I will have to get that, definitely get some things touched up on the solder side of things. First order of business was to get the tube out of the way. That'll give me a nice big access to these boards without having to mess with the controls and things like that. So this ring can stay. The way the tube comes out is very nicely. The way this one was put together, all the cables came over on one side, and there was enough slack on this one where I was able to move this out of the way. There's 2 posts here. See, good picture. So there's these 2 posts here. Those clamp on the back of the tube. Pull those out, and then the tube can just lift up and come out the back this way. I am going to get this tube out of the way. I want this put somewhere safe where it is not going to fall, shatter, break, do anything stupid like that. And I want to get this completely off the bench where it's not going to have any accidents and in a safe place before we continue. This tube shipping box for a unfortunately bad 576 tube will be fine to put this away. One thing to note is in this cover, it does not lock into this shielding at all. And on this particular one, the rubber is still in very nice shape on the tube clamp. It's not even degraded or hard or slimy or anything like that. So for being as old as it is, that rubber's in amazingly good shape. So we'll put this X foam back in the back so this tube doesn't fall over. Just like so. Now we have a nice piece of foam holding the tube on the face on another piece of foam down at the bottom. And this box will now go on the shelf. Okay, one thing, one word of safety. Always, when handling a vacuum tube, make sure you're very, very careful. Treat them with the same respect that you would treat, say, a live hand grenade. And that's not an exaggeration. Especially some of the Tektronix tubes and things like that. They are extremely high vacuum. If they hit the ground and they shatter, they can implode, which means the glass will crush itself into a powder, and then it will explode, showering you with glass and a not good time. So use extreme care when handling CRTs, and especially with some of these electrostatic CRTs, they do not have the shadow mask that a TV does. The front face of an old style television is actually pretty durable because it's got a whole bunch of layers. The shadow mask is up there, which is a steel grate, and a few other things. And the glass is super thick. On these CRTs, that's not necessarily the case. That's why all of the tech scopes that I have, they actually have implosion shields just in case the tube decides to pop while it's under power in the device. I haven't heard of that ever happening, but Tech was worried enough about it to put an implosion shield between the user and the tube. So especially when handling CRTs and large vacuum tubes, especially high vacuum tubes, use extreme care and be very careful. The rubber bumpers for the tube supports, they feel okay. They're actually not even hard. They're still nice and soft. So all in all, for the age of this thing, it's in amazingly good shape. So with the tube removed, gives me access to the power supply board from the back, which will be nice just to pull the caps off. But we'll start with this big guy and get him out of here. Pardon the state of the bench. It's been a pretty intense night of restoration so far. So I've got my meter bank hooked up to the 3 capacitors that are replaced. Turns out these boards did not age well either. There's a lot of they're very fragile working on these PCBs, so I'm gonna have to be super careful when I do the touch-up soldering and things like that. I gotta work really fast, and I may or may not be able to use my desolder tool because I may kill pads, which I definitely do not want to do. So I don't have the tube in. Everything's out still, but I'm at a point where I can fire the scope up and at least sanity check the power supply, make sure nothing explodes, and go from there. I have it hooked up to my Variac isolation transformer and current limited supply. We're on a power strip, one of the isolated power strips on the bench, and I'm monitoring the current draw through my PM100, and we will turn it on. I've got 150 volts, 180 volts, 170 volts on the power supply, and I'm drawing about 52 watts. Here are the 3 meters hooked up. The one on the end isn't even used at the moment, but that's working, so I've got good power at the caps. And then for those that are curious about the power metering, we have the PM100, which is watching the power supply, 121 volts and 500 milliamps. Well, I figured I would test one of the axial capacitors that I pulled out of this power supply, and it turns out it is very leaky. So I'm pushing 100 milliamps into this capacitor, and I'm asking for 15 volts, and I'm only getting up to about 6.6. You can see it slowly climbing-ish, and then it drops down, and then it climbs up-ish. So it's slowly, you're kind of watching the capacitor reform on the source measure unit, but this is still a lot of current. I mean, this is 100 milliamps of current, not microamps, milliamps. So this capacitor is very much a resistor and fails some testing. So it's a good thing these were coming out and getting replaced. Okay, everything in the power supply that got replaced was 1,000 microfarads of some voltage. The blue ones were 15 volts. The silver ones were 25 volts. I didn't have any. All I had was 1,000 microfarad or 1,200 microfarads at 35 volts. So that's what everything got. If we did our job correctly, no smoke, no sparks. We're hooked up to the current limited and variac supply, got nothing on the bulbs, and we are sitting at 49 watts. So nothing energetic happens, and it's just cooking right now. So that is not a problem. Okay, let's see what we have after reseating some ICs to just freshen up some contacts. All the ICs are socketed in this, and a lot of the ICs are in this sweep circuitry. So I have the Y1 position on, and we will... Ooh. Well, I have a trace now. And more problems. So this is a more rudimentary scope than a tech scope is. This actually doesn't have a trace rotation on it. I knew that going in. Needless to say, this is mildly horrific in terms of rotation. Almost more curve tracer than scope. But the way we get around that is we physically rotate the tube. Now, the problem with this is any kind of magnetic field that the scope is exposed to will actually change the trace rotation. So every time the scope moves location, sometimes even depending on what equipment is nearby, location in a lab, the trace rotation will have to be set. For convenience sake, tech scopes, they give you a control on the front. You tweak it with a screwdriver. For some of the older scopes that didn't have that control, you have to crack them open and physically rotate the tube. This goes without saying. This is extremely dangerous because you have to handle the tube while the scope is powered up. All the high voltage is there. Obviously, you need the trace and everything. So do not do this if you're not feel comfortable with this. Be very careful with what's going on. These scopes can and will be lethal with some of the voltages that are in here. The high voltage sections in these are no joke, and some of them can source quite a bit of current. And on others, they have quite a bit of high voltage. Acceleration voltages and tech scopes and things like that can hit the 26, 27, 30 kV. So 30,000 volts. We're starting to get into some spicy voltages there. When I do the alignments on the tech scopes, we actually measure the high voltage supply pre-multiplier. So even pre-multiplier, it's 4-ish odd thousand volts negative. Then you kick it through a 3-4x multiplier or more, and you have a spicy meatball. So we'll bring a trace up. I will get some gloves because I don't even want to do this with my hands. So I'm going to get some work gloves and we'll tweak the tube. Okay, I've got some standard work gloves. No, I do not expect these to be power insulators. We will be keeping the fingers well away from the backside of the tube. I hope. Nope, can't get any grip on that. Dang it. Do this barehanded. I did not want to do that. Now I'm using the center of the graticule to rotate the tube. And then I'm coming down next to the camera just to see. And I also do not want to slip because there's exposed voltages. There's exposed voltages back here. There's exposed voltages back there. There's exposed voltages back there. Back there. All over the place. And I really don't want to get zapped. So ground this and ground that. That's about as good as I'm going to get it. Let me bring the camera down so it's straight on. This parallax problem is going to be the bane of the recording. But as you can see, we have the tube centered up. So I'm going to shut the scope down, tighten the clamps, recheck it, and we will go from there. The parallax issues, because I can pop this off, the parallax issue is going to crop up quite a bit because you have angles coming in on the top where now it looks off by, just from standing, it looks off by 0.4 divisions way up here, when if you look at it straight on, it's down here. So that's one of the things, one of the benefits you get with a tech scope where the graticule's baked into the front of the glass. Okay, the tube is back home and the clamps are tightened and everything, and that trace looks really good. This tube is in very good shape, very low hours, and should be good for the maker space that this is destined for. What I'm going to have to do now is, I believe at this point the restoration is done. I did clean all the pots and the switches and everything like that, but I need to get the alignment procedure out of the service manual. Now, fortunately enough, I know the person that built this scope, and I have all of the documentation for it. So we're going to get this thing hooked up to some of my gear here in the lab. We're going to hook it up to some of the calibration stuff that I use for the tech scopes, and we're going to give this thing the best alignment it's ever had, because we can. But day-wise, because through the magic of editing, I will probably do that tomorrow because it's getting quite late here in the lab, and I don't want to wait on all the gear to warm up. Okay, I've got the scope queued up to do the calibration measurements. The calibration on this one's going to be quite short. There are far less adjustments in this particular scope than there are in a tech scope. So the first one is the vertical amplifier. We do the adjustment on the 200 millivolt range. I have it set up now and comparing it with my PG506, the calibration generator. And I have the calibration generator dialed in, but it's telling me that the error on the scope is right at the borderline, so probably 7.85% low. Because if I turn it into 1 volt standard here, we can see it decreases just a little bit. So we will need to give it a little bit more gas on the vertical amplifier, which is fine. Now I have the camera set directly square on, so you guys are going to have a better view than I will. I'm actually using the camera as a magnifying glass to look at the scope dead on. The neat part about that is I have, it's very easy for me to see what you guys see. So we're going to tweak this calibration pot here real quick. I get a tool on there. This is channel 1. Now I overshot it just a little bit. There we go, right there. Okay, so now we do the same thing for channel 2. DC, ground that, 200 millivolts. On, actually, let's off that, on that. This comes up. And that's a trigger. Nope, that's not that. That's a this problem. There we go. Actually, we want it on Y2, so it stops. Okay, so... Well, this thing hasn't really lost its alignment because they're both off by the same amount. So that probably means that when this was set in the beginning, the standard was wrong. So this hasn't drifted much over the years, but the signal source was off by about 8%. Now, in the book, it tells you to use the 1 volt peak to peak here, which means this was probably off by about 8% when this was initially calibrated. We have much better references available to us here in the lab today than we did when this was assembled originally, which is fine. And there we go. That's our alignment on the verticals. Now we need to do sweep. Okay, our X scale is pretty far off. So this particular service manual wants us to take readings from here to here. So we need to stretch it just a touch. And I have to tweak both the controls at one time. And that looks pretty good. So we have good time marks on that one and good time marks on that one. So this was not too far off. Okay, because we can, and we have the appropriate tools, we're going to just dial in the 1 microsecond, which is the trimmer capacitor right over here. We're just going to tweak this. We're not going to do the square wave because we don't need to. I've got 1 microsecond time marks. So we are just going to dial that in like so. Bit more. Having the proper signals for doing these makes a world of difference. Okay, my XY cal is off by a little bit, just the same amount that the other ones are off, so it had to be a signal problem for the initial alignment. Where's my XY cal pot? Let me find that, and then we'll tweak that one. Okay, it's hard to see, but my 5x multiplier is off too, so I have to adjust that, which we will do now. Right there. There we go. That's our 5X calibration. Here's our XY calibration. Back to the square wave, or I mean back to the 1 volt peak to peak signal from the calibration generator. So we have 1, 2 divisions, 3, 4, 5, and we're good to go. We'll check chop blanking real quick. Chop blanking looks good. We don't see anything in between them. So that is fine. Let's check what some square waves look like. Okay, I have a fake probe here, and it's compensated very well. We'll check channel 1. Take this out of here. Channel 1's a little out, but I can bring this back into compensation like so. So it is within the probe compensation range. I've gotten some comments on these before. This is actually a Tektronix RC normalizer. Adjusting these is just fine because this is essentially a dummy probe. Now the problem is I'd like to do the rest of this alignment with the probes that are going to be used with this scope, but I don't have them, so I don't want to tweak the compensation too much without those. So at this point the alignment's going to be pretty much complete until I can get this back to its original owner. Adjusting these is just fine. So when you're doing a scope adjustment, one of the things to be cautious of is you don't want to normalize to the exact input of the scope. If you're doing measurements where the coupling of the input of the scope is of primary concern for the measurements that are being done, this isn't the scope that you're going to be using. You're going to be using something much more modern, much newer. This is to make sure that probes, so what's going on here is by adjusting this and setting it once and then not touching it throughout the calibration process, you're adjusting all the attenuators to match each other. That's the important part, is they match each other. Less so have an exact input impedance here, just that you don't have to readjust the probe every time you change the attenuation. Dialing in the exact input impedance is on the scopes. That's that's about third on the list of what's important. All the attenuators matching each other, and the fact that you can bring them all into alignment is of chief importance. This is also pretty heavily coupled. This is my 47 picofarad one, so it's a much heavier coupling on this input than on, say, a tech scope with about 20 picofarad. It's also much slower, too, so we're dealing with a 10 megahertz scope versus a 200 megahertz scope. So, but that is actually going to be it. Let me get everything put back together, and I'll be back. Okay, there we are, all boxed up, ready to go. So I just put the cover on, and as you can see, the trace went off to the side again. So what I'm going to do, because I can take this off, I'm going to take a grease pencil and I'm going to just pencil in the trace on the screen, pop this in when I get down to where it's going, pull this off, and then do the final alignment there, because I could do that here, but as soon as I did that, I'd take it down there, and then it wouldn't be right again because it changed environments. So where's this going? This is actually destined for a makerspace. The original owner wanted me to get it ready to go, get it all set up, and he's going to offer this up as a scope for young kids to kind of cut their teeth on, get some things going, and work on some projects under supervision, of course. So there we are, and here at the lab we are very thankful we can help out with educational projects and things like that, getting this gear into the hands of people who need it and can use it. So also keep stuff out of the landfill. That's it for today. This is ready to go back, and I will see everybody in the next video. More is always on the way.